Hi, and welcome back. Today, we are diving into self attention, an important concept in modern machine learning. Let's get started. This is a transformer neural network, the backbone of AI models like ChatGPT and Google Gemini. At its core is attention. When processing the input like this sentence, attention allows large language models to focus on relevant information while processing the input. Let's consider this sentence. She dove into the ocean and the dove flew over her. Here, the first dove is a verb and the second dove is noun. We can understand the parts of speech by looking at other nearby words like see for the first dove and the word flew for the second dove. Similarly, attention mechanism compute attention score to identify each word's significance based on the context. Before we start, it is important to understand that every word is converted into numbers for processing and calculation. Let's take an input. This call you have made is not perfect either. Each word is converted into a vector, say x1, x2, and so on. These are known as embeddings, which is passed into the attention mechanism. Now, let's move on to understand how this attention mechanism works. Take the word this with its embedding x1. First, it's multiplied with specific weight matrices to create three vectors: query, key, and value. These weights are learned during training and are fixed. So, what do query, key, and value represent? Think of query as a source term, which represents what we are looking for. Key is the identifier of the word, determining the relevance with the query, and value is the content or the actual information. Each word's embeddings are multiplied with these weights to generate their query, key, and value. So we got embeddings and calculated query, key, and value of each word. Now we'll calculate scores. This is the query of the word multiplied with the key of each word. For instance, for the word this, we multiply its query with the key of each word. Similarly, for the second word girl, we multiply its query with the key of each word and get the output like this, known as attention filter. To prevent the product from becoming too large, we divide this by the square root of dimension, which is the number of features. For this example, let's consider dimension to be 7 and we get this. These scores are then passed through a softmax function to convert them into probabilities, highlighting the most relevant words. By now, we converted the word into embeddings and got query, key, and value. Then we multiplied query with the key of each word to get attention scores, which was then divided by the square root of dimension, and finally softmax function was applied. Now the next thing is to multiply the softmax output with the value. This is the output after applying softmax. We multiply it with its respective values. After that, we add them. Here, SP1, SP2 are calculated multiplying softmax output with the values per the word. So we sum them. Performing this calculation for the word this gives Z1 its self-attention score. This process is repeated for every word in the input. Behind the scenes, all these calculations happen simultaneously. The embeddings are multiplied with weight matrices to get query, key, and value matrices. Then the query matrix is multiplied with a key matrix, which is divided by the square root of the dimension and passed through softmax. The output is multiplied with the value matrix to get the final self-attention scores. This is how self-attention score is calculated. Self-attention is an important component of transformer architecture which powers modern AI. There is more to explore in Transformer, so don't forget to subscribe to keep learning with us.